Okay, so here we go. So lesson 5.4, part B, we're still analyzing graphs of these polynomial functions, but now today we're going to be using desmos.com to graph it as our graphing calculator. All right, so let's just jump into an example and then we'll see what we need to find. Okay, so example 1, it says use desmos.com to graph each polynomial function. So let's just stop there and let's do that first. So go ahead and for function number 1, it says f of x, which is the same thing as y. So type in y is equal to x to the 5th. So to get x to the 5th, go to this keyboard at the bottom, click it, and then at the right here, a to the b power. That's the button you want to push to get the exponent. Press 5, and then move your cursor to the right to get out of the exponent. Minus 2x squared, and you can just press the square button right next to the a to the b button, plus 2. All right, so there's your graph. Okay, so now let's go ahead and copy this onto our notes. All right, so we want to graph this, and we want to graph it with like these kind of important points. So if you kind of hover over these gray dots, it actually tells you what the coordinates are to 3 decimals. All right, so you can see that one at negative 0.868, this one at 0.2, this one at 0.928 and 0.9866. So go ahead and you can plot a sketch of those. But I also would plot like this point right here, like -1, -1. That's a pretty solid point right there. So I would include that on my graph too. All right, so go ahead and start sketching that graph on your notes while I switch over to my iPad. But before I switch, any questions on this Desmos graph?
Wait, so for homework, we're just gonna like type in this for homework into the desmos.com and just
To help you
sketch
graph?
the graph.
Right, but then you're gonna sketch the graph on your homework still.
But that's it. That's like all we have to do.
Well, no, there's more directions that we have.
Oh, okay.
Yeah. And oh, thank you, Luke. You can also press Shift 6 to get the exponent. Okay, nice. Little shortcut there. Okay, so let me switch to my iPad. And then let's make a sketch of this graph. Okay, so then I'm going to kind of highlight those key points on my graph here. 0, 2. It's a pretty solid point. This hits the x-axis, a little shy of -1. But at -1, -1, there seems to be a pretty solid dot there. This one at the minimum right there, and just kind of do a sketch for the rest. All right, arrows at the top and bottom. And there is your graph. All right, any questions about this graph? Okay. So we've done the first part of the directions. Let's go on to the second part. So it says, estimate the x coordinates at which the relative maxima and relative minimum of each function occur. All right, so I see I have a relative maximum right here. All right, and they want the x coordinate. All right, so the x coordinate for that is 0. So I'm going to say x is equal to 0, and there is a relative maximum. And yes, you do need to specify if it's a maximum or minimum. All right, and then there is a relative minima right here. Now, this one doesn't hit right at 1. In fact, if you go back to Desmos and hover over the point, If you look at the x coordinate, it's 0.928, 0.928. It says here to round to the nearest hundredth, so 2 decimal places. So I will round that to 0.93 for a relative minimum. All right, any questions on that?
I have a question.
Yeah, go for it, Michael.
Is this lesson gonna be on our test?
Probably.
Are we gonna be able to use Desmos?
Probably.
Okay.
I'm not making this one, so I'm assuming yes. Yeah. All right. Cool. Let's go then to our last part of the directions here. State the domain and range for each function. All right. So for the domain, I am going to scan along the x-axis. So pretend, right, you have a vertical line. All right, I'll draw a vertical line here, and I'm going to move it along the x-axis. So I'm going to scan, 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 and I want to see where is their graph. Well, this goes all the way to the left, and this will continue on to the right indefinitely. So if I scan across the x-axis, I get graph everywhere. All right, there's no point where I don't have graph. So this will be all real numbers. All right, and then for the range, I'm going to do the exact same thing, except I'm going to scan along the y-axis. So I have a horizontal line, and I'm going to bring it up and scan along the y-axis. And since this goes all the way down and this goes all the way up, I actually have graph everywhere along the y-axis as well. So that means my range is also all real numbers. And that's the end of the directions. So that right there is my final answer. Okay, any questions? If there are no questions, why don't you guys try number 2 on your own, and then I will call on volunteers and see what you get. All right, so go for it. Try number 2. Okay, let's see what you guys got. So for the graph, it's hard to get a volunteer for the graph. So let me go ahead and just graph it and see if you guys got a matching graph. Key points I found were 1, 0. Okay. 0, -3 was a pretty key point there. All right. -1, -2 was a pretty good point there. The relative max next to that up here, and then another one right here at -2, -3. Okay, so my graph ended up looking kind of like that. Rough sketch. All right. Cool. Let me go ahead and get some volunteers for the relative max and min. All right. Yuki, let's start with you. Go ahead and you can pick relative max or relative min. I'll let you decide.
Is the relative max x equals 0?
Relative max or min? Which point are you looking at?
The 0, 1.
Oh, this, oh wait, 0, 0, 1 would be here.
Oh, sorry, 1, 0.
1, 0, this one right here?
Yeah.
Oh, okay. That one I would say is not either a relative max or relative min, because it basically, a max would be at the top of the hill, or a min would be at the bottom of like a ditch. So that point, it hits the x-axis, but it's not at the top of a hill or at the bottom either. Does that make sense?
So the relative minimum would be 0, 3.
There you go. Yeah.
-3.
So here, I totally agree. This is a relative min. Now, Yuki, do they ask for the x-axis or the x coordinate or the y coordinate?
X.
the x. So what's the x coordinate of that point?
2, 3, 0,
Which one?
0.
0. Yeah, exactly. So yeah, don't let the -3 sway you. That is the y coordinate. We want the x coordinate. All right, so that x is 0 is your relative minimum. All right, good job, Yuki. Okay, let's go to the next one. Maya, there is a relative max. And what is the x coordinate for that relative max? 2 decimals, please.
Okay. I'm not really sure,
That's okay.
but would it be like would it be like the other like dot on like the x-axis? I don't know, but like would it be like 1? No, it's not.
No.
Um,
Mm-mm. So remember, you're looking top.
the little
You're
yeah.
looking at anything at the top of a hill or at the bottom
Okay.
of the valley.
Then it'd be like 0. What like that'd be like negative. Is that right? Negative like 1 point something.
Yeah. So did you type it into Desmos?
Yeah, I did.
Okay. So hover your cursor over the point you're looking at and tell me what the x coordinate is.
Okay. Negative 1.333 and negative 1. Wait, hold on, I can't read.
Well, Maya, or not.
Negative 1.815.
Okay. Now, Maya, the directions. What do they say? Give the what coordinate?
The x coordinates.
Okay. So what's the x coordinate? And it says round to 2 decimals.
Okay, the x coordinate is negative 1.3. Right. So 2 decimals would be just negative 1.
2 decimals.
No, wait, that's negative 1.30.
Wait, what was the coordinate you said? The what did the computer Desmos give you as this point
Well,
score?
when I typed it in, like for the little, yeah, for that point, it was negative 1.333 and negative 1.815.
Right. So the x coordinate is negative 1.333, right?
Yeah.
But we want that to 2 decimal places. That's 3 decimal places.
Yeah, so it's negative 1.30.
No, 3, 3.
Oh, okay.
Right? Two
Yeah.
decimal places. It's 3 decimal places. I only want to go up to 2. So look at the one right behind it. Do you round this up or down?
Down.
Down, because it's from 0 to 4. You keep it as is. If this number was anything from 5 to 9, you would round this up to 0.34.
Yeah, okay. Remember, that was like, okay.
Okay?
Yeah.
Okay, so make sure you know how to round decimals. Okay, that's very.
Yeah, no, I like brain farted. Like, that was my bad.
Oh, okay. All right. Just make sure, yeah, you know how to do that. Okay, so is that a relative min or a relative max?
Max.
Good. All right, because it's at the top of the peak. Okay. All right. Good job, Maya. Thank you. And let's go on to domain and range. Domain, Michael, help me with domain.
The domain is all real numbers.
Excellent. All right. And help me with the range, Ryan Lee.
All real numbers.
Perfect. All right. Good job. Now, question, is it always going to be all real numbers for the domain and all real numbers for the range? No, it's not always going to be that. Okay. So don't think that it's just always all real numbers, all real numbers. For example, I can easily have a graph that looks like this, for example. And let's say this goes 1, 2, 3, 4, 5. then this domain would be all real numbers. And does anybody know what the range would be for this one? Anyone?
Less than or equal to 5.
Nice. There you go. All right, because then there's no graph above 5. It stays at 5 or below. Okay, so again, I don't want you guys to get a false sense of security that domain and range is always all real numbers just because these two examples had it. Okay. All right. Any questions?